easy, James here. Now this is just a quick warning about a particular LED product that's available on the market at the moment and why you're going to want to leave it well alone, because it is bad news. Now can I just start by saying I love LED bulbs and the whole LED technology as a whole. It's come a long way since it was first introduced, and I actually remember when the first LED bulbs hit the market. I was actually doing my apprenticeship at the time, and I gotta say they were bloody awful when they first come out. There was two flavours. There was the cheap nasty plastic GU10 lookalike, which had the 5mm LEDs in the front, and they were awful. The light output was terrible. They were apparently supposed to be equivalent to a 35-watt GU10 halogen bulb, and they were nowhere near. I've seen more light shining out of my bum. Now also as well, the colour rendering was awful. It used to make everyone's skin look grey, and they just didn't last very long. They'd fizzle out after about 2,000 hours, so really you were no better off than buying halogen bulbs. It was also the candle style ones, which again the light output was terrible. They had the little plastic prism thing in the middle which used to reflect the light out. Well, what light there actually was to reflect out anyway. And again, they were horrible, and if you left them on too long, they would go a funny colour as well, and the plastic used to discolour, so you stopped getting light out of them after a while. So yeah, they were pretty nasty, but they've come a long way since then, and now we have bulbs like this. Now this is actually the exact same construction as a normal incandescent light bulb. It's actually made of glass. It's a glass bulb, and as you can see it looks exactly like a normal globe style incandescent light bulb, and except in the middle there is LED filaments. Now those little yellow strips in there are little strips of LED filament, and they're coated with a phosphor. Now this particular one is a 5-watt LED, and it's equivalent to a 40-watt light bulb, and as you can see that is actually really quite bright. Now you can't really tell at the moment because I've got all the video lights on, but in real life I assure you this thing is plenty bright enough to stand up to, you know, the likes of a 40-watt light bulb. Now this particular bulb is actually made by a good manufacturer. It's a very high quality bulb, and they actually offer a 3-year warranty on this bulb. So very good. We're pretty much there now with the LED technology. Now there's only one slight issue with these bulbs, and that is that they're actually quite pricey. They're between sort of £6 and £10 depending on the wattage. So if you wanted to upgrade all of the bulbs in your house with these LED bulbs, realistically you're looking at sort of between 60 and 100 quid basically. So that's going to get quite costly. So a lot of people are still not quite there with these, and they're sort of thinking, nah, they're just too expensive. But a lot of people use this logic of, well, you know what, I'm going to have a look online because they're probably cheaper. And you'd be right, they are cheaper. And you'd probably be suckered into buying something like this creation. Okay, this hideous looking item is called a corn on the cob bulb, and so called because it's shaped like a corn on the cob. Now, despite the fact that this thing looks minging, this bulb actually cost £3. £3 from China, delivered to my door. Okay, so for 3 quid, I mean, yeah, it looks pretty minging, and if we actually power the bulb up, you can see, yeah, it is actually quite bright. You do get quite a lot of light off it. The light quality is not amazing, but then again, it's 3 quid. What can you expect? So yeah, not bad. Now, before you go running off and typing corn on the cob bulb into eBay, wait a minute, because there's quite a few issues with this bulb. Now, the first one is the packaging, or the complete lack of thereby. There is absolutely no packaging with this bulb. That's exactly how it came. No box, just wrapped in paper with my name and address on it, and that was it. So no box, how crap. That doesn't fill me with confidence. The product doesn't even have a packaging. The second thing is there's no writing on there. Nothing, no markings at all to indicate the voltage, the light output, or anything, what voltage it's designed to operate on. For all I know, you know, this could have been mistaken in the packaging department. This might have been destined for the US market, where they operate on 120 volts, and I could go and put this into my light socket in the UK where we operate on 230 volts, and the bloody thing could explode or burn my house down. So that's not very good. Nothing on there at all. The only thing that is on there is a little CE sticker on there, sticker with a little CE. Now that, normally the CE is a declaration of conformity, and that means that this product conforms to the EU safety standards for electrical items. Now that's not what this sticker means. This CE actually means Chinese export. So, and it's not even printed on there, it's just on some cheapy little holographic sticker which could just peel off. So that doesn't fill me with confidence straight away, so that's not very good, is it? Now the third problem with this, there is quite a long list of problems with this bulb, is this bulb is going to be very unreliable, and I guarantee you it will not last 5 minutes. And I'm going to do some basic calculations now and show you why this bulb is going to be terrible for reliability. Now, as I said before, there's no markings on here to indicate the actual power draw of this lamp, so we're actually going to do some basic maths now to work out what that might be. Now there's actually 8 rows of 6 LED chips around the side, and there's 12 on the face, so that makes 60 LEDs. Now these are called 50/50 LEDs, and they're typically driven at about 3.5 volts. There's 3 LEDs per chip inside here. Each one is capable of a maximum of 30 milliamps, and let's face it, they're going to be driving this thing to the max. So each one of those chips is going to be driven at 90 milliamps, because there's 3 LEDs in there, all driven at 30 milliamps, so 90 milliamps per chip. So let's work out what the voltage drop across all these LEDs are. So if they're running at 3.5 volts times 60 is 210 volts. So basically they're dropping 210 volts across all of these LEDs. So if we now multiply that by the current that each one of these LEDs is being driven on, then we will get the power, overall power of all the LEDs in series. So 210 times 90 milliamps, which is 0.09 amps, equals 18.9. So we're talking 18.9 watts, which is quite a lot, I've got to be honest. So now I can do what the manufacturer seems to be incapable of doing, and we will just mark it. So basically, give or take, it's a 20 watt bulb. Now that is very, very excessive for the type of lamp design that this is, a very poor design at that. So if we see what each one of these is actually dissipating, so 3.5 times 0.09 is 315. So each one of these is dissipating 315 milliwatts. Okay, so it's 0.315. So times that by 6, and we've got 1.89 watts. So each one of these strips is dissipating 1.89 watts of heat, and it's only on a silly little aluminium plate. There's no heat sink or anything in there, and this one actually has 12 LEDs on the face. So if we times that by 2, and we're talking nearly 4 watts. So almost 4 watts is being dissipated on just this thin aluminium plate. And I mean, that's all it literally is. There's no heat sink in there whatsoever. So this bulb is not going to last 5 minutes. These are going to be severely overheated, and this will just fail very shortly. Right, so just to confirm that and to check that my calculations are in fact correct, I am now going to power this thing up, and here I've got a little plug-in energy monitor, and I'm going to plug this in, and this will tell me how many watts this bulb is actually burning. So you can see we are 18.5 watts. So as you can see, my calculations were pretty much bang on the money. Now I'm not being funny, but I can actually feel the heat coming off of that bulb right now. Just holding my hand near it, I can actually feel it. And what you find with these, the failure mode is fairly scattered. So because there's 3 LEDs per chip, you'll find that actually one of the LEDs will then go out, and the other 2 will end up drawing the excess current that one isn't, and you'll find that it'll just scatter itself around, and eventually they'll all just unevenly distribute light, and then that's it, the bulb's knackered. So yeah, pretty poor, I've got to be honest. As I say, the light output's actually very good, but the thermal design is just absolutely poor. Now if I unplug this now, I'm not being funny, but this bulb is actually like uncomfortable to touch, and if I touch the aluminium, it's actually, I can't even keep my finger on it. It's actually really hot. Right, so what I've done is I've put a little thermocouple on the end of that bulb there, and I've only just powered it up, and we're going to see what temperature it actually goes up to. So we're up to 49, 50 degrees C, and it's rising pretty rapidly. And I mean, we're not talking hours or minutes, we're talking seconds. It's not even been a minute, and it's already climbed 5 or 6 degrees since I plugged it in. So do you know what, I dread to think what temperature this will actually get up to, but I'm only going to film for another 30 seconds or so, and already that's just going to be far too hot. It's just climbing and climbing. So after being plugged in for only about 2 minutes, it's already shot up to 84 degrees C. So no wonder it was becoming unbearable to touch. That's like the sort of temperature that your cup of tea is going to be at when you pour it out the kettle. That's ridiculous, that's very excessive. So yeah, as you can see, these bulbs are just not going to last 5 minutes. It's simply just running far too hot. So I think I might as well switch it off now. It's just still climbing. It's just going to constantly climb and climb until it gets to ridiculous temperatures. So we'll just we'll call it there, I think. Now on top of all of that, there's actually an even bigger problem with this bulb, and it's a safety issue. This bulb is dangerous. It is absolutely lethal, and it could kill you, and I am not exaggerating. If you have this exact bulb, I urge you, do not use this bulb. Throw it straight in the bin. Do not use it. Okay, I'm going to show you now why this thing is so dangerous. Now the problem with the design of this LED bulb is that all of the LED contacts are actually exposed. You can see them all there, and you can actually touch them. They're completely exposed, and so are the wire connections that come up onto the board. And there are also some other wire connections down inside there which you may be able to see, and that one is a little bit sticky out here, and you could probably touch that one. Now that in itself isn't actually a problem if the power supply inside here is like an isolated power supply, either some kind of switch mode power supply or something with a transformer to isolate this from the mains. So like this bulb, for example, which I've actually just pulled open, as you can see, this one actually has a little switch mode power supply inside it, and there's a little transformer there, and there's a little isolation groove cut into the board. So you can see there's an isolation there between the high and low voltage side of the board. So this is perfectly fine, even though I can literally just twist that cover off, and then the contacts are actually completely exposed. I could put my fingers in there and touch them, but that's not a problem because all the high voltage stuff is on this side of the board, and you can see the bulb connects to the low voltage side. So this is an isolated power supply. The power supply that's inside here is not going to be something like that, not for £3. I know exactly what's inside here, and it isn't that, and I will get to that in a minute. Right, so what I'm going to do, I'm going to power this bulb up. What I have here is a voltage indicator, and this is what us electricians use to test whether something's been isolated correctly before we start to work. Now I have put it on a proving unit, so I know it does work, and basically there's a load of LEDs on there, and the LEDs will light up depending on how much voltage there is, and you can see the voltage marks are on the side there. So the higher up these LEDs glow, the more voltage there is present. So what I'm going to do is I'm going to power this bulb up, and I'm going to take this probe and I'm going to put it on the screw of my plug socket, which should be earthed, and I'm going to touch this on any one of those contacts. Yeah, and as you can see, it's any one of those, it's lighting up, and it's going right up to the 230 light there. So basically all of those connections are actually live, and yeah, that one's actually gone just a bit above 230 there. It's getting onto the 400 light. So there is actually mains potential on all of those connections on there. So if you was to touch that, you would get electrocuted. Now I know there's mains potential that exists on the outside of this bulb and it can be touched, but what I want to know is actually how much current there is available on there, because it's surprising how little current it takes to actually do you some very serious harm. So the threshold of perception, that's the point in which you feel it as an electric shock and go, ugh, that's only 2 milliamps. Now 10 to 20 milliamps is called the hold on current. So that's the point in which the current flows through your body and it interferes with the electrical impulses from your brain and your muscles tense up and it makes you unable to let go. Now 30 to 40 milliamps, you're going to start suffering chest paralysis and you're going to be unable to breathe. 50 to 70 milliamps and you're going to suffer ventricular fibrillation. That's when your heart basically flutters and beats out of rhythm and eventually stops. And pretty much anything from 80 milliamps on and you've got a very strong likelihood that you're going to be dead instantly. So that's not a lot. That's just a tiny bit more than what it requires to actually charge a modern mobile phone. It's really not a lot at all. So now I'm going to test it and see actually how much current is available on any one of these live points. So I've actually got a multimeter here which is going to be measuring current, and here in line with the meter I've got a little 50 watt GU10 halogen bulb. Now at 240 volts at 50 watts this will draw about 200 milliamps to glow at full brightness. I hope it doesn't actually glow at full brightness, but we'll see how much current is actually available between that and, well, potentially your finger. So let's power this up. Alright, so the lamp's on. Let's touch that. And as you can see, we've actually got 69 milliamps there. So that's quite a lot. And as you can see, the lamp's actually failed. It's probably done the power supply in. But, oh, it's actually only done half the lamp in. But the current is actually still available and it's gone up now. Look, 70 milliamps. That's ridiculous. So yeah, the lamp has actually completely failed now. But, well, it's still a hazard. You know, you're still going to get a nasty electric shock off of that. That's 66 milliamps there. And that's, you know, pretty much double what is required to actually do you a serious injury, if not kill you. Right, now I'm going to open this up now and show you what's actually inside here, and there's actually not a lot. Because of the simplicity of this power supply circuit, that's actually what makes it so dangerous. All that's inside here is a little capacitive dropper, and I know that for a fact because the amount of power that I was drawing there was just ridiculous. So to open this thing up actually highlights another issue with this bulb, as if the list isn't long enough already. And that is, to open it is basically like opening a pot of Pringles. Look, pop, look at that. So that literally just pops off of there, and basically inside there you have the little capacitive dropper circuit. Now I'll give you a better view of this in a minute, but inside there is the capacitive dropper. Now that capacitor there with its exposed lead is actually connected directly to the mains. So the only thing between your finger going in there and touching something that's connected directly to the mains is a silly little plastic cap that can just be popped off. So that's not good, and I'm not being funny, but the overall build quality of this thing is just shocking anyway. It just literally falls apart. It's crap. So yeah, not good. These boards aren't held in with anything at all. They're just slotted in, and that's pretty much it. So let's pull the capacitive circuit out and I'll show you actually how simple this is. And it's just glued on with a bit of Celastic. Right, okay, so well, I'm not even going to bother being careful with this one. I'm just going to snip the wires out. Let's remove all the lamps because they're crap. Right, so this is a capacitive dropper circuit. And basically it's a very, very simple circuit. There's a few diodes on the back to rectify it to DC. And it uses a combination of a resistor and a capacitor to limit the current to the circuit, and there's a small filtering capacitor on the output, and essentially that is it. And this does not isolate from the mains, because you cannot rely on that resistor to give you any kind of isolation from the mains. Okay, that's just not good enough. You need some kind of isolation transformer or something. This is not acceptable for something that's completely exposed. Now, I'm not being funny, but if all of these lamps were in some kind of you know, container, like contained within plastic, that would be fine. If these can't be touched and they're actually contained inside something, then this is perfectly acceptable. But because these are all completely exposed, this is not acceptable. You cannot use this. And also they actually bothered to put a couple of bleed resistors on there, and they are to discharge the capacitors once you disconnect the power from the lamp. So essentially it wouldn't store any energy. So if you took the lamp out of the light socket and touched that, you wouldn't get a shock from the capacitor. So they bothered to actually put those on there, but it's kind of, you know, counterintuitive, and it's kind of, you know, negated by the fact that you'll just get electrocuted when the bloody thing's on anyway. So why they bothered with that, I don't know. This has got some Chinese writing on there. I bet you this is a standard board. They knock these out for about 2p a board, and you know, they just put these in all kind of lighting products, whether or not they're suitable or not. So yeah, shite. So there you go, not good at all. Now if you have one of these bulbs, then what I suggest you do is not use it and chuck it in the bin. And if you are tempted to buy one, watch this video first, please. And basically just go by the logic of this. If it seems too good to be true, then it probably is. I mean, £3, really? So basically use your common sense. If it seems suspiciously cheap, then the likelihood is it's going to be poorly designed and possibly dangerous. So there you go. I hope this video has been a help. If you've got any questions, feel free to bung in below in the comments section, and I'll try and reply to those as quickly as possible, and I'll also put any relevant information in the description below. So there you go. Thank you for watching. Nice one.